It doesn't matter how efficient your burn is if you're not efficiently extracting and utilizing the heat. Hey everyone, this is going to be part 2 in a series I'm doing about reimagining wood stove efficiency. The first video built on the idea that one of the factors that makes wood stoves less efficient than they could be is that they're also acting as a radiator. So they're intentionally casting a lot of the heat out into the room, which is the main purpose. But that is going to result in a cooler interior firebox, and a cooler fire generally means a less efficient fire, a less complete burn, and more emissions going up out of the flue pipe. So in the first video that I'll link below in the description, I built a wood stove that's insulated, and the goal is to keep as much of the heat inside the stove so that it actually increases the burn efficiency and converts more of the wood to usable heat. But then the stove isn't actually warming the room, and you can see in that video with the thermal imaging that as the stove was emitting 1700 degrees out of the flue, I was able to touch the sides of the stove. They were barely warm at all. So it worked really well at containing the heat, and I'll try to do some testing down the road of actually how efficient the burn is. And that brings us to this video. It doesn't matter how efficient your burn is if you're not efficiently extracting and utilizing the heat. In this video, I'll be showing you how I built and tested this prototype radiator, which attaches to the wood stove, and this is how you actually extract the heat and utilize it to warm your room. Inside the radiator is a series of channels and baffles that you can manipulate from handles on the outside to redirect the flow of the flue gases on the inside. This way you can most efficiently make use of the amount of heat that the wood stove is giving off at a given time. The front is also a door that's held in place with just a few latches so that you can really easily open the thing up to get in and inspect and clean out any potential soot or creosote. But if the wood stove is achieving a much more efficient burn, there should be a really reduced amount of creosote and soot inside the actual radiator. That also allows you to run the system with much cooler exhaust temperatures. You can extract more of the heat as long as the burn is clean enough. I'll be doing at least one more video in the series where I hook the wood stove up to a water heater as opposed to the radiator. But what's really exciting to me is being able to hook the wood stove up to a variety of devices and to use the heat in different ways. So for example, when you first light the stove, the majority of the heat could be run through the radiator. But as the room starts to come up to temperature, an Arduino run system could begin to divert the heat away from the radiator and into a water heating coil, for example. And an hour or two later, the house is nice and warm, you've got a tank full of hot water, it could automatically divert it to a third device, something like a thermal mast. You could have a cob bench, for example, that would begin to heat up in your living room. The idea is to create a really dynamic system that can automatically heat a variety of things in the house. So with that all out of the way, I'm going to jump in and show you how I designed, built, and tested this unit. Remember, likes and subscribes really help the channel. Throw your comments down below. Any ideas on how to make this better or different ways to utilize the heat? I'd love for you to help me make this system better. And if you want to help support the channel directly so we can keep making content, you can do that over on Patreon. All right, let's get to it. First, I'll just cut out the main box shape. Then I'll score the folds. Cut the pieces for the internal channeling. I'll add some 1/2-inch solid square bar to one side of the channeling to support it on the open side of the interior. I'll add the internal channel pieces before I fold the walls up because I'll have better access now. I'll fold up this one side because 2 of the channel pieces need to be welded into that side. And I'll cut out the flue inlet and outlet before I fold up the top and bottom. This piece of flat bar will help support the channeling and also the pivot points for the baffles. These are the baffle plates. And I'll slot some 1/2-inch round bar to act as axles to turn the baffle plates. I'll just add a handle to make turning it easier. So now every second tier, the ones that don't go all the way on this side, have one of these moving tabs. So that when I start the fire, I can have all of these facing up. The wood stove's connected to this hole and the flue goes out up here. So when I first start the fire, the flue gases can just go straight up as normal and it'll begin to preheat the radiator. And as the radiator gets warm, I can flip this one down. This will force the gases to come over here and back around, but then they can still go up. But then I'm preheating this chamber because the gases are going through here. And then after a few more minutes, I can drop this one down. And so now they're snaking through and they can still go out this way. And then when it's really warm, I can drop this one and it'll snake all the way through. The surface area of the whole unit is the equivalent of 20 feet of single wall pipe. So once the gases are flowing through the whole thing, it's a ton of surface area to be radiating heat out into the room. So next I'm going to get working on the door that covers the front. Again, I'll just score the folds. Now I'll bend some hinges so the door can open easily. I'll bolt the door on so that it's adjustable and easy to remove. Now I'll add some latches so I can secure the door closed tightly. I'll reinforce the bottom flue inlet with some thicker steel and add a collar to it to attach to the wood stove. And then I'll add a detachable leg system on the other side to support the whole radiator while it's attached to the wood stove. Now I'm cleaning up the inside of the door so that I can add some fire rope to seal the door shut. So here it is during the first test firing. Alright, so the first test didn't actually look very good on film, but I think it was actually pretty promising. The first thing I learned for sure is that the thermal camera will not read shiny metal. Right at the end there, you can see me spray painting the top corner, and all of a sudden it becomes visible. So one of the main things I have to do is just give this whole thing a coat of high heat paint. But then there's a couple other things that I want to do before the next test. I've already switched the fire rope from the door to the actual box itself. I welded in a rim of 1/2-inch steel around and glued the fire rope into that. I think it'll make it a lot easier, and it'll open and close a lot better so that I can get in, inspect it, clean it, which is one of the main points of this system, is that if it builds up creosote, it's really easy to get into it and clean it. So I have to be able to just unbuckle it really quickly, get in and sweep it out. There were no signs of creosote from that first burn, but there was a little bit of soot right at the bottom. But that means it's getting a pretty complete burn, just not quite hot enough to burn all the soot. But that's one of the things with this wood stove, is that it's a really hot burn, so it shouldn't actually be making creosote. And then if it was just a little bit hotter, or maybe I'll add a little bit of secondary air and try to get the soot burnt off. But so far, really clean burn, and this system does actually work. And then the last thing I'll do is the front panel here wanted to bow out a little bit once it got hot. It makes sense that it would do that. So I'm just gonna weld in a cross beam so that from that corner to this corner, just to make sure that it stays nice and flat against these, so that the air actually has to channel through and can't slip past. So I'll go ahead and weld that on, get it painted, and go for another test. All right, we're all set for test number 2. This is gonna look a little warm initially. It's been in the sun for a couple hours and it's black, so it's fairly warm already. But as you can see, this is pretty cold, and here we go. And I'm just gonna try to get this fire cooking pretty quickly. So this system's based on the idea that this is running as hot as it possibly can to get the cleanest and most efficient burn possible, and then all the heat is reclaimed after the fact in the radiator here. So I don't need to do a slow burn here. I'm really just trying to pump out the heat and get that temperature boosted. So here we go. I'll be using this thermal camera that TopDon sent me to visualize the heat transfer, and I'll link it down below. And I want to mention that it's a really cool tool, but when the temperatures get above about 1,000 degrees or 550 Celsius, the camera starts to mess up a bit. So while it's great for certain things, with the wood stove testing, it did prove a little problematic. Okay, the flue seems to be really starting to warm up, so I'm going to go ahead and switch the first baffle. Okay, I'm gonna go ahead and switch the second. You can really see the heat snaking up through the system with the thermal camera. So we're at about 350 here, Fahrenheit, 175. So I'll go ahead and switch the last baffle. Okay, this thing is putting out a ton of heat. Bear in mind, this is the equivalent of 20 feet of single wall flue. So it will just be radiating tons of heat into a space. So down here at the bottom we have 850 degrees, 460, 475, 340, 310, 270 over here, and 250 right here at the top. And the flue itself is about 240 degrees. Based on these numbers and the surface area, I'm guessing this system is putting out about 8 kilowatts from radiation and another 6 kilowatts from convection. So all in all, about a 14 kilowatt system. All right, so I was actually pretty pleased with that test, and I think it proved out what I'm trying to do. I would just need to make some modifications and refine the system from here. And my suspicion is that the burn was complete enough that we're not really worried about creosote. It's more about soot and perfecting the burn in the wood stove to minimize that. But I'll go ahead and open it up and we'll see how much buildup there is on the inside. Okay, so there's a little bit of soot built up. Not much is reaching the top there. There's a little bit in here. So it's not too bad, but there's definitely room for improvement on the burn efficiency in the wood stove. And then cleaning out the system becomes something really easy that you can do in just a couple minutes. And so it completely eliminates that whole side of fear of creosote buildup. The baffles still move nice and easily. There wasn't really much deformation. The fire rope stuck well. So overall, I think it's the good basics of a design. I think it would be a good idea to match the size to the stove. So I think this is maybe a little too big for the size stove I have, and I could probably keep 3 channels, but maybe reduce it, say 20%, something like that, and I think it would made up with the stove really well. And then the next stage in the design, which I think would be really cool and really take it to the next level, would be to have an automated baffle system so that you're always utilizing the heat in the exact places you want to. It's all done on an automated system, and I think it would actually be pretty simple just building on this design. So I'm going to install this in one of my workshops, test it for a month or so, see what else I can learn, see what other improvements can be made. But I definitely think that this is worth pursuing. And if I can just tweak the wood stove to get a slightly better burn, I might try to add some secondary air. Then I think the soot would be reduced even further, and then the system could become a really holistic way to capture and utilize as much energy of the wood you're burning as possible. So I'm going to get to work getting this installed in my workshop, and I've got another water heater project coming soon that's a totally different design, and it's going to test 4 different variations of it. Then I might actually be able to hook that up with this system down the line. If you've got any ideas or comments, leave them down below. I can't wait to hear what you guys think about this and any other ways I could improve it. Thanks for watching. See you again soon.